Hi, Assalamualaikum, and a very good morning I wish to all of you. We hope you guys are in a good health. Thank you for being here today. We are here to talk to you about evidence objectivity. Let us go through of today's lesson. You will be able to know the introduction, the natural conception of objectivity, issues, and instrumentalism. Not to forget, we have prepared for you an activity to do at the end of this lesson. Introducing our sweat and tears people in the making of this slide presentation. Oh, how cute. Okay, may I proceed? Now I am Farah Iwani presenting. Objectivity is defined as a good reason for valuing scientific knowledge to get an explanation of how things work in the world. It must be based on facts and free from bias. There are two terms of objectivity. Firstly, product objectivity. Science is objective in which theories, laws, experimental results, and observations form accurate representations of the external world. The products of science are not influenced by human desires, goals, capabilities, or experience. Secondly, process objectivity. Science is objective, in which the processes and methods do not depend on social and ethical values, or even perspective of a scientist. The first natural conception of objectivity is objectivity as faithfulness to facts. Nagel describes the objective perspective as the view from nowhere. The only valuable perspectives are the ones which are not affected by humans' mind and other influences. Next, we move to theory-ladenness and incommensurability. Observations are said to be theory-laden when they are affected by theoretical assumptions held by the scientists. Two forms of theory-ladenness should be kept separated. First is semantic form. The meaning of observational concepts is influenced by theoretical assumptions and prediction. For example, concepts of mass and length have different meanings in Newtonian and relativistic mechanics. Second, perceptual form means perception of a scientist depends on the standard she is working in. For example, the two groups of scientists see different things when they look from the same point in the same direction. I hope you can understand this far. If you're not, you can ask any questions during the Q&A session. We move to the incommensurability, which means no measure in common. For example, special theory of relativity appears to be more faithful to the facts and therefore more objective than Newtonian mechanics. This is because the theories in special theory relativity is more valid and useful. It is determined by two central aspects. There are theories that use some of the same terms but have different meaning. Research methods and standards of evaluation change with the theories. That's the two aspects. I hope you guys are still with me. In science, experimentalist regress refers to a loop of dependence between theory and evidence. In order to judge whether evidence is incorrect, we must rely on theory-based expectations, and to judge the value of theories, we need to rely on evidence. The scientist has to get the right answers in order to know that the experiment is working. And to know that the experiment is working, the scientist need to get the right answer. Next, we move to standpoint theory. Standpoint theory is development of certain Marxist ideas that epistemic position is related to social position. According to this view, underprivileged workers understand social relations better because they used to live under capitalist rule and get access to capitalist life as well as their own life. They can acquire the benefits of knowledge from certain perspectives that scientists cannot. Contextual empiricism is an assumption of research method as objective to the degree that it allows transformative criticism. There are criteria to achieve transformative criticism. First, avenue for criticism. Criticism is important in scientific institutions, for example, peer review. Second, shared standards. The community must share cognitive values to evaluate theories. Third, uptake of criticism. Criticism helps to transform scientific practices on the long run. Last one is equality of intellectual mastery. Intellectual mastery must be shared equally among the community. Next, second conception will be explained by Adibah Nur.
Thank you, Farah Iwani. Hi, my name is Adibah Nur Binti Mohamad Basir. I will continue with topic Objectivity as absence of normative commitments and the value-free ideas. I will cover 4 subtopics, which are: first, epistemic and contextual values; second, acceptance of scientific hypotheses and value maturity; third, science policy and the value-free ideal; fourth, freer than the tyranny of the rational method. The first subtopic is epistemic and contextual values. There are 4 roles of values in science. First, the choice of scientific research problem. Second, gathering of evidence in relation to the problem. Third, the acceptance of scientific hypothesis as an adequate answer to the problem on the basis of evidence. Fourth, the proliferation and application of scientific research results. But most philosophers of science are agreed with value 2 and 3, which is the gathering of evidence and the acceptance of scientific hypotheses. It is because the philosophers accept that the choice of research problem is influenced by interests of individual scientists and the funding parties and societies. So, the effect is it will make science become more shallow and slow its long-run progress. Similarly, the proliferation and application of scientific research results affected by personal value of journal editor and end users. The real debate is about whether or not the core of scientific reasoning, which are the value 2 and 3, which is the gathering of evidence and the acceptance of scientific hypotheses, it should be value-free. Because of the philosophers agree with values 2 and 3 only, it arises 3 criticisms of value-free ideas in terms of epistemic values. The first criticism is underdetermination of theory by evidence. The relationship between theory and evidence are very complex because the existing body of evidence does not pick out a unique theoretical account of that domain. crucial experiments, a few are correct in specific claims, but there is some error in an entire network of hypotheses. So it will affect the existing body of evidence, often under determination of the choice of element of theoretical account.
Second criticism of value-free idea is gap between evidence and theory filled by scientific values, the word simplicity and accuracy as the scientific values. For example, how we need to sketch the graph, which one is the suitable to draw the line, which one is the best fit. It will apply simplicity and accuracy in that way.
Third criticism of value-free ideas is philosophers of science tend to regard value-ladeness in this sense as kind. The epistemic values, which is shared commitments of science, the predictive accuracy, scope, and etc., taken as indicator of good scientific theory if preferring one theory over another. But not all philosophers agree with the list of epistemic values. For example, the philosophers named Platon agree with simplicity as epistemic values, but the philosophers named Macmillan does not agree with it. Thus now is about epistemic values part. So now we move to contextual values. The contextual means non-cognitive, which is values that not related to knowledge values. The list of contextual values are moral, personal, social, political, and cultural values. The cultural values, which consist pleasure, justice, equality, and etc. Please remind that all cognitive values that involve on scientific reasoning will win the epistemic values. In example, in cultural value, it consists equality values. So the problem of this equality is occur when it involves racism. For example, the scientist that created theory of relativity was condemned because the inventor was Jewish, named Nikolai Tesla. The other example is preference bias. For example, any cases analyzed by feminist philosopher of science in biological theories. So all sponsors are biased and very picky.
Next, the acceptance of scientific hypothesis and value neutrality. The main reasonable for discipline created 3 lines of criticism to value neutrality thesis. First, epistemic values not epistemic at all. In example, Helen Longino said that epistemic values such as consistency, simplicity, breadth of scope of fruitfulness are not purely epistemic at all. Second, the use of language. There is an argument for the word thick in scientific hypotheses that are misinterpreted. Third, the scientists make value judgment. The scientist named Richard Rutner debate the difference between value neutrality thesis and context of discovery or justification. Rutner's arguments are: first, no analysis of method of science would be satisfactory unless it contains some statement that will affect scientists either accept or reject the hypothesis. Second, no scientific hypothesis is ever confirmed beyond reasonable doubt. So, contextual values are main characteristic to accept or reject the hypothesis, while value neutrality thesis VNT disapprove it. There is an American philosopher named Isaac Levy. He tried to say value neutrality thesis, while Isaac argued Peter create alternative argument 3 schemes of values, which are: first, a broad scheme, which means the set of commitments around which someone's life is organized, such as personal goal or personal ideal. Second, a cognitive scheme, which means knowledge a person, especially for their own sake, or their own practical consequence. Third, a probative scheme, which means concern more specific question a researcher find worth to follow.
Next, science policy and the value-free idea. There are three components of value-free idea. First, impartially, theories that accept only in virtue of their contribution to epistemic values. Choice of theory not influenced by contextual values. In example, truth and accuracy. Second, neutrality. Theories that make no value statements, only concerned with what there is and not what it should be. Third, autonomy. Scientific agenda shaped by desire to increase scientific knowledge. There are no place for scientific values. Next, science policy and the value-free idea. There are three components of value-free idea. The criticism of value-free idea. First, descriptive level. Autonomy of science often fails in practice due to presence of the external interest. In example, funding agency. Second, value-free ideal does not desirable at all. Value-free ideal should be withheld. Douglas stated that epistemic authority of science can be removed from its autonomy by distinguish between direct role, which means reasons in themselves, and indirect role means helping to decide what should count as a sufficient reason for choice for values in science. Assessment of evidence may affect indirectly by contextual values. So, Douglas did his conception of objectivity. He stressed a banning for value to replace or dismiss scientific evidence, which is detached objectivity. He suggests to rescue scientific integrity and objectivity by keeping values to their proper role. But unfortunately, his proposal not very concrete when it comes to implements, because there is no standpoint and the practical point of view. Next, Feyerabend, the tyranny of the rational method. Feyerabend is a powerful person in philosophy literature. He against rationality and objectivity of scientific method. He also threat for objectivity, which located in contextual values only. He turned this view upside down, the tyranny of rational method and emphasis of knowledge. He denies that value-free ideal and value neutrality thesis are Western science is loaded with harmful values. He mentioned that objective, value-free scientific method not only epistemic. He narrowed down perspective and made less free, open-minded creatives in our thinking. So, to be concluded, a community will use science and scientists in a way that agrees with its values and it will correct the scientific institutions in its core to bring them closer to these aims. Next, I will pass to Nurul Aisyah.
Thank you, Adibah. Hi everyone, my name is Nur Shahimi, and I will proceed to the last natural conception of objectivity, which is objectivity as freedom from personal biases. Scientific objectivity as a form of intersubjectivity. What's meant by intersubjectivity? Intersubjectivity is a term coined by social scientists as a shorthand description for a variety of human interactions. Science is objective to the extent that personal biases are absent from scientific reasoning. But if they can be eliminated
in a social process. All science is necessarily perspectival. We cannot sensibly draw scientific inference without a host of background assumptions, which may include assumptions about values. But scientific results should not depend on researchers' personal preference or idiosyncratic experiences. Objectivity as freedom from personal biases consists of two parts, which are measurement and quantification, inductive and statistical inference. I will proceed to the first part, which is measurement and quantification. Measurement is often thought to epitomize scientific objectivity. When you cannot express it in numbers, your knowledge is of an inadequate and satisfactory kind. Measurement can certainly achieve some independence of perspective. Examples: yesterday's weather in Durham, UK may have been really hot to the average North Eastern Brit and very cold to the average Mexican, but they will both accept that it was 21 degrees Celsius. Moreover, making sense of measurement result requires interpretation. Measurements are always made against a backdrop of metaphysical presuppositions, theoretical expectations, and other kinds of belief. Measurement and quantification help to reduce the influence of personal biases and idiosyncrasies, and they reduce the need to trust the scientists or government officials, but often at a cost. We also want to describe relations between the quantities and make inference using statistical analysis. Let's move to the next part, which is inductive and statistical inference. The question is, can we identify an objective concept of scientific evidence that is independent of the personal biases of the experimenter and interpreter? And inferential statistics is the field that investigates the validity of inferences from data to theory. This part has 3 points, and the first point is logical probability and Bayesian inference. Carnap is interested in determining the degree of confirmation of a hypothesis relative to a given set of observations. To calculate the degree of confirmation, Carnap comes out with this formula. Carnap probability logic has often been described as an inductive automaton. Closely related to Carnap's logical probability framework is the Bayesian approach to confirmation and evidence, developed by Frank Ramsey. The probability is used for quantifying a scientist's subjective degrees of belief in particular hypotheses. These degrees of belief are changed by conditionalization of observed evidence E and making use of the Bayes theorem. And this is the Bayes theorem that Frank Ramsey developed. Modern Bayesians prefer to measure degree of confirmation in terms of the increase in degree of belief. For solving a plot problem, Bayesian statisticians almost uniformly use the Bayes factor, that is the ratio of prior to posterior odds in favor of a hypothesis. Bayes factor can be written as this formula. The Bayesian approach can eliminate personal bias by imposing additional constraints on an agent's rational degrees of belief. One way to do so consists in adopting obtain the principle of maximum entropy. And this is the formula for this principle. Second point is frequentist inference. The frequentist conception of evidence based on the idea of the statistical test of a hypothesis. The strength of evidence against the tested hypothesis is equal to the p-value. Based on this figure, the p-value smaller than 0.05, it is classified as significant evidence, while a p-value smaller than 0.01 is called very significant evidence. The p-value represented as the shaded area under the probability density of the tested hypothesis. The strength of the evidence depends on which result could have been observed, but were not observed. And the last point is likelihood-based inference. A middle ground between frequentist and Bayesian inference is provided by likelihood-based inference. In this approach, the canonical measure of weight of evidence is explicated as this formula. Likelihoodists cannot use subjective probability in order to transform a composite hypothesis into a simple one. Summing up our findings, no statistical theory of evidence managed to eliminate all sources of personal biases and idiosyncrasy. Okay, that's all from me, and I will proceed to Syahirah.
Thank you, Miss Aisyah, for your explanation. Okay, hello everyone. I am Nur Syahirah Mohamad Fauzi, going to continue this lesson. Now, let us look at the issue in spatial science. First, we have issue related to Max Weber and objectivity in social science. Before that, we have to understand the differences between natural science and social science. As we know, natural science is a branch of science which deal with the physical world. For example, physics, chemistry, and biology. And to come up with natural law, we need to do experiment and analysis. While social science is the scientific study of human society and social relationships. For example, we have here economic or politics. To understand the social phenomena, we have to examine individuals' action. So, actually, social science does not have objectivity because social science always subjective. Why I say so? It is because everyone is not the same. Everyone has different interests. For example, we cannot simply conclude that all women like handbag because some women might like shoes but not handbag, and another woman might like makeup but not those two. So this is why social science is subjective. Max Weber said that social science is value-laden. As I said before, economic is one of the social science, right? So contemporary economic is said to be value-laden because it predicts and explains social phenomena based on someone's preference. But modern economic is said to be objective because the absence of researchers' value. Okay, the second issue is rational choice theory. Preferences are the key concept of rational choice theory. I will give you a situation. For example, Rashida is planning for her future. She realized that car and house are two important things to buy, but she chose to buy a car first instead of house. But different from Fahmi, he prefers to buy house first for his future. This shows that not all people have the same preference. But again, Rashida's preference can change next day, next week, or next month from a car to a house because preference is not consistent. Like I said before, Rashida chose to buy a car. The choice taken by her does not mean the choice is objectively optimal. The next issue is evidence-based medicine and social policy. I will make it short as EBM. EBM is a process of turning clinical problem into questions and then systematically find, evaluate, and use the findings as basis clinical decision. The problem of this EBM is delays in adoption of research evidence into clinical practice that makes patients receive expensive, ineffective, or harmful treatment. Now, let us look at the advantages of EBM. It allows clinicians and patients access to the most recent knowledge, and the knowledge can be learned by anyone and anytime. Other than that, EBM can help us to provide better treatment and services. While the disadvantages of EBM are it takes time to learn and practice. It also exposes gaps in its evidence. And to establish infrastructure for practicing is expensive. Okay, now I will conclude this lesson. So, scientific objectivity is desirable or is it attainable? Actually, it all depends on how we understood it. We have to look in details at three different conceptions of scientific objective, which are faithfulness to facts, value freedom, and freedom from personal bias. There are reasons why science cannot deliver full objectivity if there is freedom from value and personal bias. Okay, that's the end of our presentation. We would like to say thank you to all of you, and hopefully you guys really enjoy the presentation and learn something from it. Okay, if you have any question, just ask us through WhatsApp group. Okay, goodbye and Assalamualaikum.